Hey there, Josh here from Limbo CMS coming to you today to talk about root cause analysis, what it is, when it's needed, what are the key steps to conduct it, and the main techniques around it. At the end of this video, you should be able to put some of this content to practice based on the steps I'll outline. But before we dive in, remember to subscribe to the channel to get direct notifications whenever we post a new video about maintenance. So what is root cause analysis? RCA is the process of tracing the causes of an observable problem and identifying the basic underlying issue that was causing it. Fixing the identified basic problem should stop the recurrence of other problems that were originated due to it. For example, imagine a scenario where a machine stopped because it overloaded and the fuse blew. A brief investigation shows that the machine overloaded because one of its bearings had an issue. So substituting the bearing would probably allow the machine to go back into operation for a while. But if the team investigated further, they would have realized that what caused the bearing to fail was an issue with the lubrication system. Addressing the lubrication system instead of simply replacing the bearing would have maintained the machine working for much longer. So root cause analysis tries to follow the chain of cause and effects to pinpoint the problem that, when eliminated, makes all the other faults disappear. But conducting RCA can be very complicated and generally involves a vast amount of data collection. And the results are not always black and white. More often than not, we'll get only a strong correlation between cause and effect and not a causal relation. From there, an experienced professional has to judge whether to investigate further or not. This type of analysis requires domain knowledge and experience, which is not always an available resource. But in certain cases, RCA can lead to a significant competitive advantage when trying to understand and improve the fundamental nature of systems and procedures. So when do you conduct root cause analysis? Since RCA requires a significant investment of time, manpower, and money, it should not be done for every single fault. There's no cut and dry rule for when to conduct RCA, but here are some instances based on which experienced professionals can make an informed decision whether to conduct RCA or not. Persistent faults. If the same fault occurs over and over, it's worth investigating. As the same fault is reoccurring, we can deduce that the fault will not be cleared by fixing the visible problem. There are some underlying reasons for the recurring faults, such as incidents need to be investigated with RCA. Critical failure. The degree of how critical a failure is can be measured using the cost to the plant, or the total downtime due to the particular failure. When such a failure occurs, it has to be investigated to identify the root cause of the failure. This will help avoid such occurrences in the future. Explosions at an oil rig and airplane crashes are examples of critical failure that need to be investigated. Failure impact. There are critical machines and critical sub-processes in any system. A failure of such machines will halt the entire operation, as there might not be a backup or mitigation plan for that particular machine. In essence, the criticality of the machine determines whether to conduct RCA for a failure or not. Now let's go ahead and dive into the root cause analysis process. In essence, root cause analysis is used to precisely figure out what happened, how it happened, and why it happened for any incident that occurs. An easy way to think about the process is the 3 R's rule. The first one is to recognize. The true cause for an effect we observe is not always obvious. Cosmetic fixes do not do much to correct the underlying fault. The elaborate exercise of RCA is conducted to pinpoint the true cause, so we can take corrective actions that will eliminate future issues. As mentioned earlier, RCA can also be done to identify the cause for an unexpected positive outcome. The second one is to rectify. Once a root cause is recognized, the corrective course of action has to be undertaken. If the root cause is addressed, the same problem should not be cropping up again. If the same problem appears, it is highly likely that the cause identified was not the root cause. You'll have to conclude that the previous RCA conducted was not comprehensive and more investigation needs to be done. And the third one is to replicate. Once the root cause is figured out and rectified, you'll have to ensure that the same fault will not occur again in the same system in another location or at a later time. If the RCA was done to identify the reasons behind unexpectedly good outcomes, you'll have to test whether the same factors can be replicated in other scenarios and environments. So what industries can leverage root cause analysis? Faults and problems occur in almost every industry, which means most industries can use RCA techniques to investigate the underlying cause and contributing factors. The most obvious use is in medical diagnosis. That's because the same symptoms can be caused by a whole set of illnesses, and it is the duty of the doctor to identify the underlying cause before a patient can be treated effectively. And if you have ever watched a TV show, House MD, you should be familiar with this process, as almost all of their episodes are exercises in root cause analysis, though in an unconventional manner. There are many other industry verticals that use root cause analysis as well on a regular basis. Some of them are manufacturing, machine failure analysis, industrial engineering and robotics, industrial process control and quality control, information technology, software testing, incident management, cybersecurity analysis, complex event processing, disaster management and accident analysis, and risk management. But remember that root cause analysis is a structured way of thinking and investigating any type of incident. With that in mind, RCA is not just limited to the areas I mentioned. It can be implemented in any sector or industry where the root cause of a problem needs to be fished out. RCA can be accomplished using many different tools and techniques, which I'll go ahead and cover in just a little bit, but regardless of the techniques used, all root cause analysis must go through the same following steps. We have step 1, problem statement. That means a clear description of the problem and the symptoms experienced. This will give you the scope of the analysis and will also help to determine the scale and scope of the potential solution to be implemented. Now, step 2, data collection. All available data related to the incident has to be collected. Take, for example, machine failure in a manufacturing plant. Some of the pertinent information that needs to be collected includes the age of the machine, time of continuous operation, operating patterns, maintenance schedules, operators handling the machine, specifications of the machine, schematic of the plant infrastructure, operating characteristics of the machine, characteristics of the operating environment, and every piece of information available. Inspecting the machine in person also provides information that could be beneficial for root cause analysis. For facilities that collect data for predictive maintenance, it'll be easy to collate this data. So step 3 is chronology, differentiation, and mapping. This involves creating a timeline of events, which helps to determine which factors among the data collected are worth investigating. From the data collected, correlations can be found between various events, their timing, and other data collected. This can be used as an initial step to differentiate between causal and non-causal events. One important thing here to remember is that correlation does not mean causation. You cannot conclude any analysis when a correlation is identified. Causal relations need to be investigated. In step 4, root cause resolution, once a root cause is identified, the solution to fix it can be easily determined. It can be mapped against a scope defined in the problem statement. And if the solution fits the scope, it's implemented. Fixing the root cause should eliminate the recurrence of the symptoms. If the symptoms occur again, we would need to go back to the drawing board and conduct RCA again. Now let's go ahead and explore the tools and techniques used to perform root cause analysis. As I mentioned, there are many different frameworks used to do it, and some of these include the 5 why analysis, the Fishbone Diagram, aka Ishikawa Diagram, failure mode and effect analysis, or FMEA, fault tree analysis, and Pareto charts. None of these methods are foolproof, but they provide a solid base for how to go about root problem investigation. Now let's go through these techniques in more detail. 5 whys is the original technique developed at Toyota factories for root cause analysis. It is addressing everything with a why, just like a curious child. When we ask why the invisible problem occurred, we can trace its cause. Then the question why can be asked about the cause we just identified. This process can be continued until a stage where there is no need to ask why any further. At that point, we should have reached the root cause of the problem. As a rule of thumb, asking and finding answers to 5 subsequent whys should be more than enough to unveil the root cause of most problems. Hence the name 5 why analysis. The Fishbone Diagram for root cause analysis emerged from quality control techniques that were employed in the Japanese shipbuilding industry by Koru Ishikawa. As you can see on this image, the shape of the resulting diagram looks like a fishbone, and that's where the name comes from. This diagram is based on the idea that multiple factors can lead to the event we are investigating. The problem or fault is written down at the far right, where the fish head is presumed to be. The cause for it is represented along the horizontal line, and further effects and their respective causes are written down along the fish bones that represent materials, machines, the environment, methods, measurements, and personnel. This process is continued until the team conducting it is convinced that the root cause is identified. Failure mode and effects analysis combine a systematic approach of reliability engineering, safety engineering, and quality control efforts. It tries to predict future failures and defects by analyzing past data. A diverse cross-functional team is essential to undertake this type of analysis. Because each subsystem design and process must be questioned, failure of similar processes and products in the past can be analyzed to supplement the process. As potential failure modes are brainstormed, fault tree analysis is a method that uses Boolean logic to figure out the cause of failure. It tries to map the logical relationships between faults and the subsystems of a machine. This approach to root cause analysis is very effective, but is more complex than other ones. So I went ahead and created a full video explaining it, and I'll leave that link to that video in the description below. And the last approach to RCA that we'll see today is the Pareto Chart. This approach is based on the idea that there's a huge asymmetry between the ratio and the effects caused by them. In any system, 80% of the results or failures are caused by 20% of all potential reasons. With this principle in mind, failures and their possible causes are analyzed and a bar graph and line graph are drawn, with the frequency of faults and the causes for faults as well. With this graph, we are able to observe the skew between causes and failures. Usually, we'll need to discover how a small percentage of factors cause a majority of faults. The causes that contribute to the most number of faults are then analyzed further, and corrective actions are taken to eliminate the most common faults. Root cause analysis is a vast umbrella term, so it's hard to be fully explained in a single video, but I hope this introduction gave you a good base of its concept, approaches, and how to start implementing. When choosing a methodology or approach to conduct RCA, remember this, that each of them has its own merits, and certain methods are more suitable for different industries and types of problems that are being investigated. Each company and its management team should have a protocol in place to adhere to when conducting RCA. Different companies might prefer different techniques. In some instances, external consultants might be brought in to conduct RCA. In such cases, the consultants will have a preferred technique or a combination of techniques they use to conduct it. This is one of the reasons why it's hard to create a universal template for RCA that everyone can follow. Just make sure that your team is not cutting corners. If you want to get to the bottom of any complex event, rushing the process can be detrimental to the entire project. So if you have a good reason to conduct RCA, then it's in your best interest to create an environment in which the process can be executed successfully. If you are a maintenance professional dealing with complex, problematic assets, do not hesitate to reach out to one of our Limbo team members and check out how Limbo CMS can help you alleviate all your asset management problems. And there we have it. I hope you learned a lot from this video, and if you enjoyed it, make sure to go ahead and like the video, subscribe to our channel, so that way you can keep up with all the different videos that we produce about leveling up your maintenance game. And I'll see you on some of those following videos. Cheers.